So today's question is to check whether the given fraction are equivalent or not. So we're doing the number A. So I'm writing here what 5 by 9. So here is 5 by 9 and it is 30 by 54. So to whether this both 5 by 9 and 30 by 54 are equivalent, I have to multiply this one 5 by 9 both numerator and denominator with the same number, so that if I get the same number 30 by 54, then it will be equivalent. Suppose that 5 into 6, then I have to multiply in the denominator also 9 into 6. What I'll get? I get 30, 5 9 6 9s are 54. So both, so this one, what, after multiplying this fraction 5 by 9 in the denominator and numerator, in the denominator and the numerator with a common number, I am getting another fraction which is exactly same to the other fraction. Thus 5 by 9 and 30 by 54 both are equivalent. We can do it in another way. Suppose means alternative. So this is the alternative way. Another way, suppose earlier what we did, we multiplied this fraction 5 by 9 and we just out of multiplying we got this. Now if anyone want to do it like another way, suppose what happened if I start with this one, whether I'll get the first fraction. Let's see, 30 by 54. If I divide both numerator and denominator by a common number which is 6, here what I'll get, 30 by 6 equal to 5, 54 by 6 is 9. So what I'm getting exactly the other, I'm getting the first one fraction, that is, so therefore I can write 5 by 9 and 30 by 54 both are equivalent. What is there? 3 by 10 and 12 by 50. So I'm writing 3 by 10. Now, so I am equaling this one 3 by 10. If I 3 by 10, I'm writing this. Now what, just see, you need to equal the numerator of or denominator of the other fraction. If after equaling a single one, if both becomes the same, then your fraction will be equivalent. Suppose here it is 12. So if I want to make it 12, I have to multiply both numerator and denominator by 4 after, but I have to multiply it by 4 also. So what I'm getting 12, and here I'm getting what, 40. So I'm not getting 12 by 50. This is the one process. So therefore 3 by 10 and 12 by 50 are not equivalent. In an alternative way, what if I do alternative, if I think like that, let's see, 3 by 10, I'm thinking that okay, I will make an alternative way. What I'm doing, 3 by 10. Okay, earlier what I did, I want to make this numerator, it is equal to numerator to equal, earlier I want to make this numerator equal to, I want to make this numerator exactly same to the other numerator, other fractions numerator. Now I want to make this denominator equal. So what I'll do, 3 by 10. Okay, to make it 50, what I'll do, I'll multiply by 5 and I have to multiply here. So what coming, 15 is there, 3 5 is 15 and 50. Still I am not getting 12 by 50. So therefore 3 by 10 and what is there, 12 by 50 are not equivalent. Now coming to number C, 7 by 13. Now 7 by 13, that I am making 7 by 13. Now another fraction is that, what is then in this number C, 5 by number C, 5 by 11. So 7 by 13, another fraction is 5 by 11. So if I multiply it with 5, okay, what I'll come with, 35. What I am getting, 65. 13 5s are 65. Now what I am getting here, another fraction is 5 by 11. Now 5 by 11, if I multiply both numerator and denominator by 7, what will happen, 35 7 70. Still both answers are not equal. That's why 7 by 13 and 5 by 11 are not equivalent. Now here the question you may come to your mind, that in earlier what happened, both 3 and 12, this 12 comes in the table of 3. Okay, so that's why we multiply with 4 and then 10 into 5, 10 5s are 50, 3 4s are 12. Now what happened, 7 and 13, for 7 and this 5, both in the table of 7, and here is 7 by 13 11, 5 by 11. So both the number what are prime number. So both the number are prime number. So that's why I multiplied it with the other number, because in the prime number there is no common factor. So in the table of 7, 5 will never come. So in the table of 5, 7 will never come. That's why. And at the same time 13 and 11, both are also prime number. That's why in the table of 13 you won't get 11, and at the table of 11 you won't get 13. So that's why I tried to make both number equal. That's why I multiplied both numbers, something like getting the LCM of a single number. I can multiply it both by 11, okay, here, and I can multiply here also by 13. Still it won't come the same. So I'm doing it in alternative way. Earlier what we did, earlier I multiply, why I multiply it with 5, because multiplication with 5 is comparatively easier than multiplication with 11. Okay, let's multiply it. So we are multiplying both numerator and denominator with 11. So we are getting 7 11 7 11 7 that is 77. So what we are getting, 11 into 13. What we are getting 143. 11 13s is 143. You can think it like that. 13 tens is 130. So another 13 gives you 143. Next time is 5 by 11. Now we have to multiply it. What? 5 by 11. So we have to multiply it by 13. So this is 65. What is 11 13? We are getting 143. So we made the denominator equal. Okay, in both the fraction the denominator is equal, but my numerator in both the fraction are not equal. So thus 7 by 13 and 5 by 11 are not equivalent. So to do this kind of question, earlier you have to make the answer both numerator of, after multiplication you have to make the numerator equal and the denominator equal. After, if you, what we did in the earlier, here all those are prime number. That's why that's why we made this one is denominator is equal by by doing multiplication. Now in the earlier question what we did, the numerator, we made the numerator equal. Okay, so in number B, what we did, we made, after multiplication what we are getting, we did the numerator, we made the numerator equal, but denominator is not equal. But in the first one, in the number A, what we will get, after multiplication we made the numerator equal, we get the denominator also equal, exactly same. Then we try to make the numerator equal, then we divide it in a, so tried to make the numerator equal, then denominator equal, this denominator is also equal. So this is the process to check whether a given fractions are equivalent or not.